So today is Chapter 4, Lesson 3, solving quadratics by factoring. The first thing I want to teach you is if you are given roots, how you can get back to the quadratic equation. So first of all, if you'll remember, these two values, when we say roots, that's where that crosses the x-axis, okay? So I can take these roots and put them back into factored form. Right now we've solved and we've gotten the answer, but I can put them back in factored form. The way to do that is you use the factored form x minus a, where a is your root. So to write these roots in factored form, I would say x minus a negative 2 and x minus 3. Now, since these two are roots, we know that when we have our function, that means it equals 0. Okay, so let's simplify this. X plus 2 times x minus 3. Okay, and then if you FOIL this, or however you choose to multiply it out, if you multiply it back out, x times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x. And 2 times negative 3 is negative 6. All that will equal 0 because these are roots. Simplify the like terms. Minus x minus 6 equals 0. Now, if you compare this to the notes that we talked about in 4-2, you'll see that when we found these two roots from the graph, now we try to work backwards, and this is the equation that we started with. Okay, so I could rewrite it as a function by saying f of x equals x squared minus x minus 6. Okay? You need to remember how to factor. There are many different methods of factoring, and the review unit covered factoring. If you're not really good with it, then I suggest you go back and review all of those videos. I'll post them in this section, but review all of those videos so that you'll know. Let's look at this first problem here. I can factor this by taking out a GCF. Both of these values have a 3 in common, so I can take out a 3, and both of these have at least one y, so I can take out a y. If I were to multiply it back in, what's left is a 3 and a y here. Notice when I multiply it back, I get 9y squared, which is what I want. Plus, well, I took all 3y, I took it all out, so I only have 1. Remember, you have to multiply it back, so I need to represent this. I have to have 1 back here. Equals 0. Now, anywhere that you have a variable, you need to set that expression equal to 0 and solve. So there's a variable here, so I say 3y equals 0. And there's a variable in here. All of this is together, so I say 3y plus 1 equals 0. Now solve both of these equations. Divide by 3, divide by 3. So here y equals 0. Subtract 1. 3y equals negative 1. Divide by 3, divide by 3. So y equals negative 1/3. These two values are where the quadratic, the parabola, will cross the x-axis. Okay? All right, these are the solutions, and we solve by factoring. Let's look at this one. Again, I can take out a GCF. The number I can take out is 5. And the variable, each of them have at least one a, so I can take out an a. And I'll have just an a left up front. That will make 5a squared if I multiplied it back in. Minus 4. And of course, put equals 0. Anywhere that there's a variable, you set that expression equal to 0. 5a equals 0. A minus 4 equals 0. Divide by 5, divide by 5. A equals 0. A, if I add 4, equals 4. These two answers are my solutions. This one, it's hard to see. It says y squared equals 36. If I'm just solving for y, I need to undo the square. So to undo a square, you take its square root. Now, since I'm solving, I'm not just simplifying. When you solve, you say, well, what values could y be to give us 36? Well, y could be a positive 6 or a negative 6, so you put plus or minus. Negative 6 times 6 is 36, and positive 6 times 6 is also 36. Okay? Over here, you have to look at the factors of the first term and the factors of the last term. Whatever you choose, the last two numbers have to add to give you this middle term. When you combine your like terms, you've got to get the middle term. So what I do is I say, well, what are my two values that give me x squared? We know that x times x is the only way to get x squared. And when we look at 9, the factors of 9 are 1 and 9 and 3 and 3. In this case, because the values up front here are 1, I don't have to worry about anything changing the middle term. So I look at these two things and I say, which ones will multiply to give 9 and also combine or add to give me 6? And the only ones will work is this 3 and 3. So I'll say 3 and 3 and check your signs. When you multiply, you need to get positive, and when you add, you need to get negative. So the only way to do that is a negative times a negative. All right, so we have x minus 3 equals 0 and another x minus 3 equals 0. We don't have to write it twice. So x equals 3. Now look, it looks like it's only one time. This is going to be the graph that goes, here's 3, and it just goes down and touches and goes back. Now, if you had to write the function like up here, and I only gave you one root, you still need to represent it twice. Okay, we'll talk about why later, but you still need to know that there should be two answers there. All right, let's try this one. Again, the leading term has a 1 in front, and so we just say x and x, because x times x will give us x squared. We're looking for something to give us 15 when multiplied, negative 15, and a negative 2. So we can think 1 and 15, or 3 and 5, and that's about all, okay? And so which two numbers will combine to give you a 2, 3 and 5? And so we're going to need one of them to be positive and one of them to be negative, okay? So in order to get a negative 2 here, I need a negative 5 and a positive 3. Let's just check. This is x squared. This will be negative 5x. This will be 3x. And this will be negative 15. So our x squared and our 15 are fine. Negative 5x plus 3x will give us negative 2. If we solve, we get x equals negative 3 and x equals 5. Now the last one, a lot of people don't like it because it starts with a number in front of x, a leading coefficient that's not 1, but it's not really, don't let it scare you away. We know that the only way to break up 5 is 5 and 1. So the factors are 5 and 1. You don't have to put a 1 over here with that x, but it doesn't matter. Now 24, I can use 1 and 24. I can use 2 and 12, 3 and 8, and 4 and 6. Okay, those are the possibilities. Now I'm trying to get close to 34 in the middle, but I have to remember this 5 is going to multiply. To make the middle term, this 5 is going to multiply with this number and add to whatever goes here. So as I look through these, this is going to put me way off. If I put a 24 here, Or I do a 24 here plus 5, that would be 29, but that's not going to work. Okay, 12, I'll be at 60 if I put a 12 here, so that's not going to help. But if I put a 2 here, I'll be at 10. 10 and 12, that's not going to work. Okay, 3 and an 8, I'll have 40 and 3. So that's close, but it's not going to work. But here, I can put a 6 here and get to 30, and put a 4 here and get to 34. And since they both have plus signs, plus plus, and now we just set them equal and solve. 5x plus 4 equals 0. Minus the 4, 5x equals negative 4, so x equals negative 4 over 5. And then x plus 6 equals 0, x equals negative 6. So if you're feeling uncomfortable with factoring, please make sure to rewatch those videos because we're going to be doing a lot of it. But this is how you solve quadratics by factoring. Hope you have a wonderful day. Ask me any questions if you have any. Bye!